Hello and welcome to the second day of mixture problems. These kind of mixture problems are called grocery problems because they have to do with food. In fact, the first problem deals specifically with cheese mixes. We have Parmesan and Romano cheese. Parmesan costs $3.50 per kilogram and Romano costs $5 per kilogram. How many kilograms of each type of cheese should be used if we mix them together to make 100 kilograms or $3.95? So let's look at this for just a minute with what's happening. You're taking one kind of cheese that costs a certain amount, and you're mixing another kind of cheese that costs a certain amount to make a mixture, and you want a certain amount of that mixture, and you want it to be specifically worth this amount. So we have to mix things in the right ratio. Well, the tables make this easy because we're basically going to do a distance equals rate times time table again. In fact, all of these are like that. For the first one, first row, I'm going to call this Parmesan cheese, and then I'm going to have Romano cheese. And you have to make sure you set the table up correctly. This isn't as easy as distant rate time because we have to make sure that these match, but this is a lot like the investment problems we did yesterday. My rate, which I could start with, actually we'll put rate in the middle because that's where we put it, rate times time. Oh no, we did rate times time equals distance. We'll put rate at the beginning. We'll go rate, and we'll have that rate be a cost per kilogram because that's what these units are. $5 per kilogram, $3.50 per kilogram, it's a cost per kilogram. Then we're going to multiply that by, and you can actually tell what you're going to multiply by because if you look at the denominator of what the rate is, that's what we should be multiplying by. We're going to multiply by the number of kilograms. So you could say the number of kilograms. And actually, I could use a little bit more intelligent. I can use this term mass. That's a science term, better than weight. But you know what? It's food, so we'll talk about weight. Weight's probably a little bit better for food context, even though they should say mass. Weight in kilograms. Rate and cost per kilograms times the weight in kilograms, and that's going to equal the, I could say, total cost. And, you know, you can put dollars. We know it's dollars. So that's the setup for, like, all of these. The rate for the Parmesan cheese was 3.5. The rate for the Romano was 5. The weight, okay, we've got another case here where we have a total weight. That would be the 100, so I'm going to put a total here. I have a total weight, and I don't know what the weight of the rest of them are, so I'm just going to pick the first one as W, and the second one as 100 minus W. It is important that you know that it is the total minus the part when you do the 100 minus W, and also to know that these two could be interchangeable. The question asks how many kilograms of each type of cheese, so we're going to have to answer for each of them anyway. So it doesn't matter which one we pick. Now, for the rest of this, it says we want to produce 100 kilograms of a mixture worth 3.95. So for the mix, so I was going to say total, but this is also the mixture. The mixture's rate is 3.95. Okay, let's do our multiplications. 3.5 times W is 3.5 W. 5 times 100 minus W is 500 minus 5 W. And then we have a new technique, something I do. I call it splitting the cell. What that means is that, how do I get this final cell? Well, I could add these two, and I could make it 3.5 W plus 500 minus 5W. That's one way we've gotten it. Or what I could do is multiply these two and make that 395. Well, strictly speaking, it's actually both of them. In fact, that's our equation. We set both of them equal to each other. So what I will sometimes do is not even write that final cell. I'm just going to go straight to the equation. 3.5W plus 500 minus 5W equals, and that would be 3.95 times 100, or 395. We'll split that cell and do that again here in a few minutes, but let's simplify the left. That would be negative 1.5W. Subtract 500 to the right side, and that's negative 105. If I divide, I get W is equal to 1050. If W is equal to, oh sorry, not W is equal to 1050, W be equal to 70. So if W is equal to 70, that means that the other one, 100 minus 70, was equal to 30. And then I'm going to state this in a complete sentence answer. You need 70 kilograms of Parmesan and 30 kilograms of Romano. Moving on. A grocer, I know, more food, wants to mix 12 pounds of egg noodles with costing 80 cents a pound with 30 pounds of spinach noodles costing $1.20 a pound. What will the cost per the pound of the mixture be? So I have egg, and I have spinach noodles. I have a rate that is in dollars per pound. I have a weight in pounds. Rate times weight is equal to total cost, that's in dollars, and my rate for the egg is 0.8, the rate for the spinach is 1.2, we have 12 pounds of egg and 3 pounds of spinach. What will the cost per pound of the mixture be? That's the variable, and that goes right here. That's going to be X. And so we'll call this last cell the mixture. You should know what the weight of the mixture is. 12 plus 13 would be 15. Then we multiply. 12 times 0.8 is 9.6. 3 times 1.2 is 3.6. I'm going to do the same splitting the cell thing where I take the sum of the product of the bottom two, 15 times X, and I add these two, so it's actually coming from both of these, and those become the two sides of the equation. That'd be 13.2. Divide by 15, 13.2 divided by 15 is 0.88, and the cost for the mix is 0.88 per pound. It's important to put that per pound because that's what our units were right back up in the table. Let's continue on. Flip it over. How many kilograms of raisins at $4 per kilogram should a grocer mix with 15 kilograms of nuts at 6 kilograms per pound, or $6 per kilogram, sorry, to produce a snack mixture worth this amount? Step back. Don't look at the specifics of the problem. Look at the big picture. We have raisins, we have nuts, and then we have a mix of the two of them. So, raisins, nuts, and mix. The raisins, we're going to do a rate, and I'm going to do the units of rate, dollars per kilogram. We have the weight in kilograms. And then finally, we have the cost, or the total cost, in dollars. The rate of the raisins is 4. The nuts were 6, and this mixture is 4.75. How many kilograms of raisins, that's our X, should the grocer mix with 15 kilograms of nuts, that's our 15, and then the mixture should be the sum of these two, X plus 15. Did it produce? Okay. So then we do total cost, 4X. Then I have 6 times 15 is 90. I'm going to split the cell again and do the product of these two equals the sum of these two. 4.75 times X plus 15 equals 4X plus 90. Distribute 4.75 X plus, this would be 71.25, is equal to 4X plus 90. Subtract 4X from both sides. I get 0.75x. Subtract 71.25 from both sides, and I get 18.75. Yes, I am using a calculator for this, and so are you. Divide both sides by 0.75, and I get x is equal to 25. Since the question just asks for raisins, you just say we need 25 kilograms of raisins. Talk about juice. Juice company mixes apple juice and grape juice together for its fruit punch. We can put apple, grape, and the punch, which we can call just a mix. Okay, we have a rate. The rate this time is more like a cost per. This would tell you what it is. The cost per liters. And we can kind of decide, do we want this to be in cents or dollars now? I would actually keep it the way that they have it and have it be the rate in cents per liter, since those are the units that are given. We don't use cents a lot, but we can use it here. Liters is a unit of volume, so I'm going to put that volume instead of weight. And then total cost. And this time we absolutely need to put that that's in cents and not dollars if we mean cents. So, how much should the company charge per liter if they mix 6 liters of apple juice, selling at 85 cents per liter, so that's 85, with 8 liters of grape juice selling at 62 cents? Where are we going to put the variable? Well, then go back to the question it's asking. It says, how much should the company charge per liter if they mix, or with the mix? So it wants to know the cost or the rate for the punch. So that's going to be a variable. Call it x. Then the rest of this I can fill in. 8 plus 6 is 14. That's the total volume of that mix. 6 times 85 is 510. 8 times 62 is 496. Split the cell again. This is kind of an easy problem now because it's just x times 14. Remember, you do the product of these two. It's still rate times time equals distance. Or in this case, rate times volume equals cost. And then you add these two together. So I'm going to kind of delete those because I don't want that to get confusing. But 14x equals, add those, you get 1006. And that means x is equal to 71.9. That's 71.9 cents per liter. So what we can answer is the company should charge 71.9 cents per liter. Yes, you could have done dollars with this whole thing. It just would have been a little bit more decimal numbers, but it would have worked. Okay, last problem. Grocer wants to mix nuts costing $5 per kilogram with nuts costing $8 per kilogram to make a 10 kilogram mixture selling at $6 per kilogram. So I'm going to call these, we have $5 nuts. We have $8 nuts. And then we're going to have the mix. Okay, same thing, we have a rate, dollars per kilogram. We have a weight in kilograms. And then we have a total cost. And that total cost is in dollars again. The rate is 5, 8, and the mix would be 6. All that came from the problem. How much of each type of nut should be mixed to make a 10 kilogram mixture? So our mixture is 10, which means that one part here could be W for weight, and the other one is 10 minus W. So really this all depends on where your variable is. And we didn't have a variable in either part of the $5 nuts or the $8 nuts, so we pick it, and then we have to do the total minus the part again. Total cost, 5W, 80 minus 8W. Split the cell. 6 times 10 is 60, so that's one side of the equation. Then we have 5w plus 80 minus 8w for the other side of the equation. Gives me negative 3w equals negative 20, or w is equal to 20 over 3. I don't like decimals, so I'm going to say 6 2/3, not do 6.6 repeating, because that's annoying. 6.6 2/3 kilograms. And then I have to subtract that from 10 for the other one. 10 minus 6 2/3 is 3 1/3. So those are my two masses, or my two weights, sorry. So what we say is we need 6 2/3 kilograms of $5 nuts and 3 1/3 kilogram of $8 nuts. Done.